Hello, my name is Jeff Nolan, co-founder and VP of Solutions for Agile Handover. Electrical outages in data centers can cost millions per hour, but most facilities are still relying on static, outdated, single-line diagram PDFs of their electrical system. That means knowledge lives in just a couple people, training new employees can take a long time, and planning or troubleshooting is very complex and also risky. The reality is, your electrical system is dynamic, but your tools are not. Our solution is called CircuitSim. CircuitSim changes all that. It's a web-based platform that turns your single-line diagrams into a live, interactive simulation of your electrical system. Instead of guessing what happens, your team can actually see system behavior, test scenarios, and provide training. Let me show you what that looks like. Here we have a high-level view of a site distribution diagram showing two buildings at a high level, building one with two sources coming in and, and a generator backup, and building two with two sources coming in with a newer battery type backup system. This gives new hires a really quick view and a detailed understanding of how the system works at a high level. It also provides site planners with the tools they need to assess different work that must be done. For instance, if work needs to be done on the main switchgear, we can simulate shutting that equipment down and see the downstream impacts. Data rack A loses power while B and the mech yard are fine. Things must be now put in place to ensure that data rack A has power. All these scenarios can be quickly tested using the tool. From here, we can dive into a more detailed view of the same building. Here we see the same building with the power coming all the way down into the server racks and the buses that feed them, as well as the network operations center and the mechanical yard cooling towers. From here, we can now simulate real operations. For example, opening a main breaker and transferring to generator. Also, if we attempt something unsafe, the system enforces fail-safe logic, just like in the real world. If I try and power this switchgear from two sides, we get an explosion icon on the screen. Every action within CircuitSim is tracked in the back end. If I zoom in to the Network Operations Center and open up the alarm window, you'll quickly see what I mean. If we lose power coming in, the UPS automatically kicks up and the battery power comes in. We can see that all shown over here in the alarm window. If the battery loses power, we get a report saying that the buses are no longer fed. This information can be copied and shared through emails or added to procedures or best practices. Also, during an incident, teams can instantly search and find the power related to what the incident is involved in. For instance, if we had something happen with one of the bus rows, I can quickly come in and do a search for bus row 12, for instance, and zoom right into that object to assess the situation. From here I can see the switchgear that's feeding it, and further than that I can easily trace the power all the way back to its source and get a quick understanding of the impacts and what could have caused the problem for the particular bus row. We can also use the tool to simulate loss of power, faults, and walk through a variety of recovery scenarios. By enabling the interactive model, the system now will respond in real time. And if we simulate a loss of power on side A by opening up the main breaker, you can see all the various timers throughout the system start to behave. In addition to opening and closing breakers, we also support many different fault simulations. And we can click on any line, bus, or breaker and fault that object and see what happens and see how the system responds. If we already lost power on side A and side B has a fault, the sensors will go off within the system, the generators will start up and provide power all the way down through to the bus rows. We can also do restore, and the same function can be run on the faulted line to restore the line, and the system will sense that the power has been restored, and the generators will shut off, and the power will flow just as normal. In addition to running a variety of simulations, we also have a training module built into the tool. The training modules are designed to guide technicians step by step through various activities. In this example, we're showing a UPS maintenance regarding the shutdown and lockout of the UPS. The training modules ensure consistency and reinforce operational procedures. Here you can see as we click through, the system responds, and eventually the UPSs are shut down, everything is locked, and we have a full view of all the steps required to work on the UPS. You can do faster planning, taking that from hours to months, safer training without real-world risks, faster troubleshooting during incidents, and shared knowledge across your entire team. Instead of relying on your tribal knowledge, you create a system that everybody can use. If you're interested, our next steps are very simple. We'll run a pilot using your actual single-line diagrams and turn them into a working simulation environment so you can see the value in your own facility. Contact us by visiting our webpage, and we will help you bring your electrical diagrams to life.